Alright, today we are doing hypothesis testing. This is where we start to get shit. Chapter 10 is on hypothesis testing, or the first part of hypothesis testing. Ten point one goes over, well, what is it? How does it work? And 10.2, we'll start doing it with a one sample proportion test.
This what you said our final gonna be on the most,
Yeah,
this part that we're learning about.
the 88% of your final exam is on hypothesis tests. Alright, so I got a deck of cards here. There we go, there's that band, getting that band fucking red. Damn it. Nice deck of cards. Get rid of the jokers real quick. Shuffle them up. So Val, you wanna know about the final, right? You wanna play a game? If you draw a red card. You and everyone in this class will get 2% extra credit for free. If you draw a black card, I'm gonna put an extra question on the test.
But that's not a pressure, am I picking it right now?
Yeah, we'll do, I'll come to you.
Oh, okay.
Now, it may sound like a negative to have an extra question on the test, but there's only 10 questions on the test. Which makes each question worth about 10%. The more questions you have on there, the less each question is worth. Like if I had 100 questions on there, they'd only be worth 1% each. And you could miss 10 questions and still get an A. If you miss 10 questions as it is now, you get a 0%. So having more questions isn't a bad, this is a good thing either way. But I'm sure you would rather have the extra 2%, right?
Yes.
So you draw red cards. You get the extra credit. Draw a black card, I have to do more grading.
Why do I set this up like this? This is terrible. Alright. Oh, that's fine.
You go again,
Black,
go again.
okay, we'll go again. I'll put it on the bottom, so you know, don't draw the bottom part.
Okay, I picked another.
I have another ace of spades, we did ace of clubs, ace of spades, okay? Now there's 2 questions, does anyone else want to try? She's bad luck.
I really am, sorry guys.
Anybody else? Okay.
So if it's red, you get.
If it's red, you get extra credit, if it's black, you got. Ace of spades. Alright, anyone else? Four spades, shit, four questions now, fuck, I'm not the only one. Good luck.
You have a 50-50 chance, like 50 chance.
Now you know that we got some black cards at the bottom, so ignore those. Alright, 2 of spades this time. Alright, that's 5. But god damn, that's a lot of. Grading sucks, I don't know, I need to set this up where I do something different. Do one more. Don't draw from the bottom. I don't want him to be more problems, get this right. She got another black card.
Dude.
Anybody else wanna try? You're already up 6, alright, let's do it.
Let's clear any pressure here.
There's a lot of pressure. Gotta get it right, everyone's gonna be disappointed in you.
Not the.
Yeah, they ignore the line. You put them on bottom.
Damn it.
Yeah, 2 clubs at a time. Alright, so. Let's talk about what hypothesis is. I got a nice little slideshow set up for you. Oh, I gotta share screen, right? And I gotta change zoom so the zoom user see it. Let's go slideshow. From beginning. Alright, introduction to hypothesis testing. Your teacher offers to make small wager with you. We did 7 times, but let's go with 6 for here. Replacing and shuffling the deck after each draw. If it's red, you get 2 extra credit points. If it's black, your final review, oh, I think it said 2 extra credit, like, I guess I got tired of giving extra problems. If I can lower it by 1, I need to change it even more, cause grading sucks, you guys, you're like, I hate doing 1 test. I have to fucking grade all your guys' tests. And the test, the final is written, it's not like on the computer, so it's, most people think the final is easier. So. Any ideas? Let's look at the probability of drawing 6 black cards, like, well, you do 7. What's the probability of drawing 6 black cards? We studied probability in chapter 5. So we had the first is a black card, and the second is a black card. And the third is the black card, and the ands turn into multiplication. And in a normal deck of cards, half the deck of cards are black and half are red. So. With 6 black cards in a row, you've got a 1.6% chance of that happening. 7 black cards in a row is half that, so 0.8% chance. Okay? So like, let's put, like, if we did this 1,000 times, through 6 cards. We can expect to see 6 black cards in a row about 16 times out of 1,000. This is possible. It is highly unlikely. You guys are either A, you're really fucking bad at this game. Or the deck was stacked against you. That's a reasonable assumption at some point. You did see me open it. I got the cellophane right there. You saw me fight with the goddamn thing. So. Outcome 2 is probably unlikely. So this is the idea of hypothesis testing. You don't know. Until I flip over that deck of cards, you don't know. You're never gonna know the solution, you're never gonna know the real answer in real life. So we gotta come down and base it on probability here. And what you're doing is you make an assumption about reality. The assumption is the deck was half red and half black. That's what I assumed when I calculated the probability. I will load this slideshow up, so if you wanna have the slideshow later on, or you wanna write down, I will pause and wait for you.
Oh, it's gonna be up on the.
Yeah, I'll upload the slides, but if you wanna write, please write.
Is it printable when you upload it? Like, does
I've
it
never-
look like this? when
It's
you-
a PowerPoint, I
Oh, okay,
assume
then.
you can print a PowerPoint.
Okay, then yeah.
But Kelly's writing, so feel free to write. If you wanna write, you write, I can wait. Why don't you pull what Krista did and say fuck everybody else? She. You know, she fucking emailed me that night and said I was right. When it was all raining and I'm like, go home while it's still like, you could go home while it's still light out. Or you can drive home in the rain, she's like, I wanna do lecture now. She sure shit, it was fucking sunny at fucking 7 o'clock when we left. She was sure to message me and let me know I was right. I'm surprised she's not speaking, holy shit. Wow, you came to class.
Yep.
That's good. What's your name again? Archer. Alright, so we made an assumption about reality, we drew cards. And you drew 6 cards. So what is a hypothesis statement? It's a hypothesis, it's a statement about a characteristic of one or more populations. For now, we're gonna focus on a single population parameter, and I'm gonna give you some examples that are not card related, like this is stuff that's bio. The percentage of milk fat in California dairy milk in 2012 was 3.72%. Researchers believe that a change in diet has changed the percentage of milk fat content. What parameter is this talking about? Remember, parameter is like a thing, like a statistic when we use samples. Parameter is the population version of the statistic. So, here's my Zoom, I can write. So like we could have, this could be about a proportion. It could be about a mean. It could be about standard deviation. Another option we haven't really covered is variance, which is standard deviation squared. Which parameter are we talking about here?
Me,
What?
the me,
Why do you think that? Or are you just guessing one? Just guessing. It's not the mean.
oh, fuck.
Where this is definitely the population. Either proportion, mean, standard deviation, or variance. There's a reason for it. Proportion.
It's only California.
Well, that's not why, but proportions are fractions, they turn into percents. They gave us a percent. So this is more than likely a proportion. What is their claim? It used to be that the proportion was 3.72%. That's kind of like the old news. What are the researchers saying? What does it's changed to mean?
Either gone up or down,
It's gone up or down. Could be either lower or it could be greater. All we know is it's just not equal. So the researchers are saying that the proportion does not equal 3.72%. That's the claim. I'll give you another scenario in a second. I didn't make it up to 3.72%, like, I don't think this link works anymore, but it did when I made this. This is actually the lecture I gave to get hired as a teacher. You have to give a lecture and present it and wanna have like an audience. And they gotta go, oh, your lecture was good enough that we want you to be a teacher, and then they let the president pick. This is why I got hired. I did the same thing with a room full of teachers, pulled out a deck of cards from them. Alright, you guys ready for more? I'm gonna hit clear on that so that I can. Go to the next slide, I gotta close that. For every increase in standard deviation of plant to plant spacing, the corn grain yield rate drops approximately 2.2 bushels per acre. This is according to research done at Purdue University. A new corn planting machine revealed at the World Ag Expo claims it has decreased standard deviation below that of its farm model, which had a standard deviation of 4.5 inches. What parameter are we talking about here? Are we going with P, mu, sigma, or sigma squared? It's exactly what it is, and that's exactly why. They told us standard deviation, and said it a couple times, standard deviation is sigma. It said the former model had a standard deviation of 4.5. That's our old news. I'm gonna say 4.5 inches. That way we know there's units. What is the new machine supposed to do? What does decrease it mean in terms of math?
Go down.
It does go down, yeah. So what symbol is that?
Negative.
Not quite. Less than. Less than 4.5 inches. So this is the claim made by the equipment manufacturer. Now, that machine doesn't exist, but it was, the Purdue thing is true on that. Spacing on corn plants, actually, like how much varying of standard deviation there is in the spacing in them. Does fuck up how much corn you'll get per acre. Bushel seems like a weird. Fucking volume, I think, I don't know, I don't do ag. I think a bushel is like a volume of corn, like I don't know how much corn that is, but. There's 2.2 bushels of them. Oh wait. Oh well, fuck it. Reset shit, I'll have this up on another slide in a second. Another example we'll do, the average final exam score for statistics students was 73%. We believe the use of computers in statistics courses has increased the average grade of students received on their final. What parameter are we talking about here? Mean. Why?
Because it's calculating the average of all students.
It's talking about average, and average is another word for mean, right? So mean. It says the mean was 73%. Now, the percent sign here might have made you think proportion or. But in this case, the word average overrides that. We're actually looking at an average. What did we think? How does this change? This is the old news. What does increase mean? More than, or greater than. So that's the claim being made by us folk that use computers in class. I'm one. Doing this class is a fucking beast when you're doing it all by hand. Trust me, that's how I took this class. Y'all got it so much easier. Alright. I don't know what the hell Kelly's looking at right now.
I took a picture.
Oh. Okay. Let's pause for a second, make sure she's paying attention in a second. The next few slides are gonna look similar to what she wrote down. Oh, no, not yet. So hypothesis testing is a procedure. This is a lot of text to write down, so it's better you just listen. Cause otherwise you're gonna be writing a while and it's gonna be less meaningful unless you follow along.
Okay.
Hypothesis testing is a procedure where we use probability with a sample, we're gonna take sample evidence and we're gonna try to infer something about the population. Now, generally, we're gonna have two competing hypotheses. It's gonna be the old news, what we assumed to be true. And then after we took sample evidence, what we think might be a change. Or you might have the hypothesis before you gather the evidence. Usually in reality, you gather the evidence after you've got, you know what, that doesn't sound quite right. So you go, I think it's higher, I think it's lower, and you'll go collect evidence to see if you're right. And you're doing it about the population, but like we can't like the statistics class, I can't find out like the average grade for all statistics users for every college student across the fucking country in a real meaningful amount of time. It's a lot of work, a lot of effort, it's not fucking practical. So we use samples to try to make the work easier, but it introduces some kind of error. Like the sample may be wrong. We saw this with the confidence interval stuff. Sometimes it, like not all confidence intervals had that, we had a 95%, 99%, stuff like that. This is related to it, it may just like, I might take the wrong sample. I could do your guys' group and you guys could all crush the final. And if everyone got a really high score in the final, it's probably not indicative of overall statistics students. Because most students are gonna average somewhere lower than an A. So. Doing one sample could be wrong, that's where hypothesis testing is not an exact science. So we make two hypothesis claims. One is the old one, we call this the null hypothesis. Then it's called the null hypothesis, it goes by H naught. And we're going to assume it's true, it's it's the prior information. So the null hypothesis is like prior info, prior assumption. Writing with the fucking mouse sucks. So this indicates like, it's still the same. Shit hasn't changed. In the case of the statistics one, computers don't help, kind of thing. It always has an equal sign in it, very important. H naught is always going to contain an equal sign. Then we have our other claim. Our other claim is called the alternate hypothesis. The alternate hypothesis, sometimes it goes by HA, sometimes it goes by H1, depending on which textbook you're looking at or who's giving the talk or presentation or research on it. It's usually the new idea. In the terms of the statistics class, we think using computers, the grade goes up, so it's the one where we had mu was greater than 73%. It is going to have an inequality in it. It's gonna have a less than, it's gonna have a greater than. It's gonna have a not equal. Oh, she showed up.
I went to a last visit, I was gonna be late.
I don't remember, I'm paying attention to what you said. That means she probably wasn't listening to me
No, I was.
heckle her.
No, I didn't mention her. I didn't remember.
This is a slideshow that I will upload. Okay. You weren't here, your entire class fucked up and drew all black cards, they were a bunch of fucking losers.
I mean, I was hearing that,
You were what?
so that's what I heard.
That's what you're, yeah. Alright, so let's go on to the next slide. So the first test we did, which was about the milk fat. The 3.72%, if we write it as a decimal, it's 0.0372. We had P equaled it and P did not equal it. This what top one was the old news, what the Dairy Association said was the milk fat percentage. But the researchers thought otherwise, so the claim is what the researchers think. And we call that the alternate hypothesis. So it's either HA or H1, I don't know if I wrote H1 on the last one. And this is like an H0, it's also pronounced H0. And it's not like this, NAUGHT. Kind of like naughty, but not the word naughty. Not means nothing. Which is another word for zero. And I think we use it because it's one syllable and zero is two syllables. We are mathematicians are a lazy fucking group. You should hear me go over how lazy we are in like an algebra class or calculus class. We come up with a bunch of shit that's confusing as fuck to students. And it saves like all of one fucking like parenthesis sign or some shit like that. Alright, so like every hypothesis test is gonna have two claims. The null and the alternate. That was the one on proportions that we did with milk fat. Then we looked at the standard deviation in the corn yield. The 2.2 bushels per acre. We had standard deviation equaled 4.5 inches. And with the claim was the machine made it lower than 4.5 inches. So this will be our H0 and our HA. Let me go back a slide for a second. We call this a two-tailed test when it's not equal. I'm not really gonna focus on the test or anything, but if they reference it in the homework or on like when you're looking at shit. When they say a two-tailed test, they're talking about stuff like this. A two-tailed test, when we're looking at a bell curve. We're just saying it's not in here. But we don't know if it's over here or over here. So it's either tail. I'm gonna leave that up there in a second, because when we change to the next slide, which we had just done. A left-tailed test. It's called a left-tailed test, it's a one-tailed test. One tail or left-tailed. It actually tells us which tail we're looking at. We think the standard deviation is over here, not over here and not here. We think it's somewhere to the left. So they call it a left-tailed test. We're only gonna be looking at the left side when we relate it to a bell curve. Not really, again, not about all that important to know left-tailed or right-tailed, but if you see it, that's what they're talking about. It does point the arrow on the inequality looks like an arrowhead. So it tells you the name of the test. Inequality points to the left, so it's a left-tailed test. If we look on next one on average stat scores, we had greater than. The greater than looks like our arrowhead on our right arrow, and so it's a right-tailed test. So our parameter can be a variety of things. It doesn't need to just be P or mu or standard deviation. When you do it in if you do take a higher level stats course, let's say you want to do data science because you're a sick fuck. I mean, even that's too fucking far for me. I'm like, no. You'll do a whole lot more stuff, variance and other things. There's more stuff. But the basis of hypothesis testing, there's two claims. We don't know which one's right. Okay? And we use sample evidence to try to make a decision. So. Did I skip a slide? No, I didn't. The null hypothesis is very much like not guilty in a court of law, it's what we assume to be true. Has everyone seen like a court TV show? If you haven't been on a jury, I'm guessing a lot of you haven't been on a jury yet, because a lot of you are young. But if you've been on a jury, you've seen this in real life, there's generally. Guilty or not guilty, they don't have a jury for like non-criminal cases. They don't do it where like one company suing another, no, they don't do that shit for juries. Juries is for criminal cases, so it's guilty or not guilty. The null hypothesis is always assumed to be not guilty. It's what we assume is true until we prove otherwise. The alternate hypothesis or alternative hypothesis is like a statement of guilt. We have to prove it. Now, in all reality, you might want to say the defendant is innocent or the defendant is guilty. But. We don't say innocent, we say not guilty. Why do they not declare someone innocent in a jury case? So you're either, if you're being charged with a crime, you're either guilty or not guilty. They don't say guilty or innocent.
Because it's they're assuming. From what they've heard but it's not 100% positive that they really did do what they said they did, they're just going off the facts.
We're not 100% positive that they're innocent. We just don't have facts to show that they did.
Yeah.
Like if you're accused of murder. Like you may have actually murdered someone and just are like really good at murder. And like fucking like wore a full suit, like and got rid and burned all the clothing. Or used like something like the weapon disintegrated, like stabbing with a fucking icicle or some shit like that. Where like the weapon is gone because it melted. Yeah, there's no. I used to work with someone that told me like at least once a week how she was planning my death. I miss her, her name was Debbie, she was great. Every week she watched CSI to determine ways that would not work to kill me. She was like an older sister and I drove her crazy working with her. So we don't say innocent because they may have actually done it. We just didn't prove it. That's the same thing here. In hypothesis testing, we might not have enough evidence to rule out the null hypothesis. But we can't actually say it's true, because we might just have a bad sample. If I wanted to find out the average income of Vicellians. And we had Bill Gates in this fucking room. It would look like the average income of people was a lot higher than it really is, right? So you put a billionaire in the fucking room, the average income skyrockets. So you might just have a bad sample. Bill Gates would be a bad sample. But generally, you don't know if you got a bad sample. So you just don't know. That's the idea with hypothesis testing. We don't know, so we're not gonna say innocent, we're gonna say not guilty. And that's gonna translate, erase. To what we do on the next slides. And we just got done talking about this, guilty or not guilty, not innocent. We can only provide strong evidence for something, and if you don't have enough evidence, you gotta kind of rule it out. We can't be 100% certain, and in the terms of statistics. Like in the case of a murder, you just may not have collected the right evidence. They might be guilty as fuck. Krista might have poisoned the cupcakes I bought. But there's not enough evidence to support that because I didn't get sick. So if she did, she's either an incompetent poisoner. Or she just didn't do it. But if I accused her of poison, there's no evidence for it. So there's a couple things that we can say, we're gonna either reject the null hypothesis or we're gonna fail to reject the null hypothesis. If we fail to reject the null hypothesis, let's start with reject the null hypothesis. We're gonna reject it. This is like saying we're rejecting the not guilty, this is like saying they're guilty. We've got enough evidence to indicate that they're guilty. We've got video footage, we got eyewitness testimony, we got the fucking murder weapon with their fingerprints on it. It's a pretty good. Strong likelihood that they were guilty. Now, sometimes all that shit can be doctored, and like fingerprints are not enough evidence. If you touch the person. Or the weapon. Whether or not it was used by you, you're still gonna have your fingerprints on it. So when we reject the null hypothesis, we're saying that if it's true. It would be surprising. In the case of murder, like. If we say you're guilty and you were actually innocent, it'd be surprising, cause we got a lot of evidence that says you fucking did it. So rejecting the null hypothesis is where we do that, we've got enough evidence to reject it. And we will say there is sufficient evidence to support the claim of the alternate hypothesis. When we fail to reject the null hypothesis, this is where. If it's, the null hypothesis is true, it's not a big surprise. Like in the case of Krista poisoning my cupcakes, there's really no evidence of her poisoning my cupcakes. This could just be me making a wild claim for no reason that she poisoned my cupcakes to, I don't know, slander her for some reason, But there's no evidence to support it, so if she really didn't poison me, it's not really all that surprising. But I never got sick, there's no evidence. And if that's the case, we would say there is insufficient evidence to support the claim. That Krista poisoned me. It doesn't mean she didn't, it means there's not enough evidence to support that she did. This is a great example. Now, those are the likely ones that happened, but we could be wrong. We could reject the null hypothesis when it's true. We could accuse them of guilt. And they were actually innocent. It happens. The legal system is not perfect. Your hands are on the murder weapon because they took the knife from your fucking kitchen and you cook in your house. Your fingerprints stay on it for a while. It's not like they did evaporate in fucking 15 minutes. They're on there. Someone comes along wearing a glove, grabs a fucking kitchen knife you have held. Now your weapon, your fingerprints are on the knife. And we've got you get eyewitness sees you holding your wife's dead body. And there's a knife with fingerprints next to you that's bloody with your fingerprints on it, you look pretty fucking guilty. But you could be innocent. And that's what this is like. This is like convicting an innocent person. So we could reject the null hypothesis when it's true. And this is called making a type 1 error. They will mention type 1 and type 2 in the book. It's not a big focus for me. If you're gonna go, anyone wanna be a statistician? Someone that does statistics for the rest of their life? Yeah, I didn't think so. Every once in a while I need a sicko. I will use that word to describe students. The other mistake we could make is we could fail to reject it when it's warranted. Like I could have came up sick. Krista could have empty boxes of rat poison fucking in her garbage can. And we could have said she was innocent and poisoned me, even though there's a lot of evidence that would have indicated she might have actually done it. So rejecting the null hypothesis. Or failing to reject the null hypothesis. When we should have rejected it, is like. Letting Krista walk free. I'm sorry, letting the guilty, I need to go back to the murder thing. This is like letting the guilty person walk free. Yeah. You were holding a dead body, your fingerprints are on the weapon. Not only that, there's fucking video footage. There's angry text messages between, bitch, you didn't make my dinner, I'm gonna come home and gut you. And then like the jury going, no, we still think that's not enough evidence. I wonder statistically, is it more wives died or husbands died? Now, I think there's more violence from husband to wife. We're going with a binary wedding here. If you're like same-sex couple, that's not, it doesn't work for the story, but let's For like man-woman marriage, generally, if there's domestic violence, it's the man hitting the woman. But like murder, is it the same thing? I almost think it's the other way, I'm kind of curious.
I think it's woman.
I think more women kill their husbands than husbands kill their wives. Cause husbands will just be like bad husbands, will be violent. But they don't take it to the point of death. And the woman will get fucking tired of getting beat. And she'll just wait till that motherfucker go to sleep, when he ain't fighting back. And you know, a quick fucking cut to the throat, it's all over, and I can fucking go to sleep. Right? I don't know. I have to look this up.
I feel like that's true.
I feel like it's more likely true.
Cause like a lot of men really fuck up sometimes, you know? And like, if a woman really loves him, she's gonna fucking go to the extent. Not saying like if she doesn't love, and I'm not saying if she don't, really kind of love him, you know?
I don't know if a lot of men or what percentage of men actually fuck up and actually strike their wife. I know. I've done this at her. But she knows I'm joking when I do this, she got madder than shit when I did that the first time. And I'm just fucking empty threat, and she's figured she doesn't back me now. She'll go like she's gonna backhand the shit out of me for no reason. Alright, so type 1, type 2 errors, we call alpha type 1. This is what we're gonna focus on in hypothesis testing. It's called the level of significance. And we wanna make this very, very fucking small if we can. The less important the topic is, the larger the number can be. If you're like talking about how successful open heart surgery is, I kind of want like you to be like a very, very high percentage of being correct. I don't want you to be wrong 5% of the time. I want you to be right, like it needs to be less than 1%. You need to have like less than 1% before you're fucking cutting open my chest and working on my heart. But like if it's like, we have a question on whether or not we should stock bugles in the fucking chip machine. Who gives a shit if we're wrong? We'll find out if they sell or don't sell. We pull them off the shelf or we stock more. And you only lose a little bit of money, but it's not like a life ending decision. So like you could have a higher level of error there. We're pretty close to the end. That was the end. Let me go back to the document camera here. And I gotta change this to document camera. So let's talk about those proportion things a little bit more. And then we'll take a break. Okay, yeah. So alpha was this is alpha, it's a Greek letter. And the other one, did I have it on there? Did it have beta? The other one was beta. Well, not beta. This is alpha, this is type 1. That is a type 2. These are errors. These are Greek letters, alpha, and it's not beta. It's actually, a lot of people say beta. But that is wrong. It's beta. This is a fun thing that I learned in grad school. A lot of we had I had a French advisor and I had an English advisor. And he would make fun of us for using the letter Z. Cause Z is only an American thing. Every other country that uses our alphabet says Z. And it's true. If every other country calls it Z, it's been Z the whole fucking time. And then someone wrote the alphabet song. And Z didn't rhyme with fucking B. So they changed Z to Z. And so only Americans call it Z, and so we got it wrong, but I had one of my fellow classmates was actually Greek. And he said beta. And she said, you ignorant English people, it's beta. And it makes sense, if you put them together. Alpha, beta. Alpha, beta. It's where we got the name alphabet. It's alpha and beta. Alright, so back to hypothesis, that is your fun but non-important statistic fact. Generally, we aim for alpha to be 0.05. This is our. And we've used it before, unusual criteria. If it's less than 0.05, it's unusual. The two-tailed test. This corresponds to a confidence interval. Of 95%. Which is 1 minus alpha times 100%. On a one-tailed test is a little bit different. You're gonna do 1 minus 2 alpha. So 1 minus 2 times 0.05 is 0.9, and we turn that into 90%. So our custom one is 0.05. If we do looser requirements, where it's less important. We could say alpha equals 0.10. 15, 20. You don't see 20 often, I can't remember if I've ever seen 20. 10% usually is like the limit, but you could go higher. And if you wanna be like more like stricter requirements. Or tighter requirements. Like, let's say you wanna make sure that the surgeon is a success. You wanna go something lower like 0.01. Or even lower, 0.01, something like that. Low. Oh, low. And choosing alpha is like part of the job. Choose alpha. Depending on. How important it is to not be wrong. Surgery. I'm going 0.01 or lower. The bugles and the stock machine. I don't care if we do 0.05 or 0.10. These are less important because. It's a short-term experiment to test to see. If we could increase sales or not, and if it doesn't increase sales. We only lost a little bit of money because we didn't have something that would sell better for a month. But if it increases sales, we make more profit, it's not the end of the world. Let's take a 10-minute break and we'll go into the full hypothesis test process. That you will use for the rest of this class. She finally fucking started it.
Prologue, that was like,
Did you finish the other ones?
like.
The shitty books your mother wants you to read?
Yeah.
You finished? Really? I'm calling. Alright, let's resume this. Let's talk about the hypothesis test. And the process. So the hypothesis test procedure. There are 5 steps. And we can almost kind of like wrap it up into 4. The first step is identify the two claims. And I don't know where I gotta be there, and label them. As H naught and H A. Remember, H naught will have an equal sign in it. And H A has inequality symbols. Two and three are kind of interchangeable. Number one really needs to be done first. Two and three are interchangeable. Two is pick alpha. Our level of significance. We're gonna go through all this in regards to our depth problem in a second. Step three. You could do this after step or before step two if you want. Find the test statistics and something called the p-value. And this is a stat crunch thing. Or a torturous process by hand. The p-value, which you will often hear me call p-val. Because adding the U is just an extra syllable and I'm too fucking lazy to say it. This shows you. The proportion that are as extreme as our case is. To give a numeric example, so this makes a little more sense. Let's say our p-value is 0.1981. Then if I did 100 samples. 100 experiments just like this. About 20. Would have results. As extreme or more extreme. Than what we got. And we're measuring extreme by how far are we from what we thought? From the center of the bell curve kind of thing. I need to add something to number two. If alpha is not listed. Use alpha equals 0.05. That's our. Normal level of unusual. Pause, let you get all caught up on this. Got my haircut and I got home and my wife didn't fucking notice.
I noticed.
You know how cold that is?
That's fucked up,
That's fucked up, right?
that's how, that's
Like, you not even never look at me? Normally she fucking spots it right away. Oh, you got a haircut, you look so great. No, I got nothing.
fucked up,
It is fucked up.
that fucked up.
Jim,
Should've.
see, I get away with doing things because the camera's pointed at you guys.
Should've saved your money, that one you could have saved your money.
No, just you go. I don't get tired of being long. Like my hair looks way better short, it actually looks masculine. Whereas my fucking Ronald McDonald curls looks like a fucking, I got a perm.
You should get a low taper fade.
Yeah, she'll really notice,
Right,
get a skin fade, get a burst fade, they're really fun.
Let's
I
get
don't know what that
dreads.
looks like.
Let's get some dreads.
Get dreads. She'll fucking notice in a heartbeat,
I tried to do a mohawk once,
she won't let you leave, you get that.
mohawk didn't work well, my hair just curls enough that like. Even when I gelled it, it wouldn't fucking dry fast enough. And it fucking looked like a curl, like a ocean wave, like part of it tipped over to the top.
You need to comb it when it's wet, that's why.
What, do you think I didn't try a whole bunch of shit when I spent like hours trying to get the mohawk to be a mohawk.
Blow dry,
I tried that, it would not dry fucking fast enough.
you're using weak gelin.
Or my hair just fucking curls really
You
quickly.
need to get the gorilla gel from
Yeah.
my art, the green
Yeah.
one.
I didn't put fucking concrete mixture in my hair. Hey, that's shit, gorilla snot's fucking tough shit.
Yeah, I think you're right.
Are you good, Kelly? Alright,
Get a taper though, bro, we should get a taper,
Fresh ass taper.
yeah, let me see if you go.
I don't trust you.
I'll put my taper, I'll
Get a
try
lineup.
this.
Get like a little lineup.
Yeah, get a lineup, she'll really notice.
And a little spray. That'll be fresh.
It has to be fresh. Yeah.
I gotta go.
I'll bring my clippers next time, we'll fucking taper.
I just got my haircut, it's nice. Alright, step 4. Compare p-value and alpha. So there are two situations here. A. The p-value is less than alpha. Or B. The p-value is greater than or equal to alpha. Now, the way to memorize this that I'm a very big fan of. How does this apply to our hypothesis test? If the p-val is too low. Reject the hoe. Reject H naught. And if we reject H naught, we support HA. Now, if you don't wanna say reject the hoe. The null must go is another phrase they do. You like the first one?
First one, third.
I think most students prefer the first one. I get teachers that like have like. Sat in on and then like did like a review, like we every 3 years, like as a teacher, you gotta get evaluated by your peers. And as long as I'm not like beating my students or like fucking just being discriminatory or fucking harassing them too much. I'm fine, but one of them's like, I really don't like that you say that. He's very good, I think he's got good, strong Christian values. And then like finds it, I don't know. If you don't like it, use the no, let's go. This one here is just the opposite. I don't have a good jingle for it. But we do not reject H naught. And we do not support HA. Pick up, Val.
Come on.
Step 5. Is gonna be state the conclusion. If option A showed up. Where we reject the hoe and support HA. We're gonna say there is sufficient evidence. To support the claim. And then paraphrase HA here. Or just copy it from the question, if it's worded right. And we'll do examples of this. And support leads to sufficient. If we went with B. Where the p-value was greater than or equal to alpha. It's almost the exact same, we're just gonna say there is insufficient. Or you could say not enough evidence. There's insufficient or not enough. Evidence on off screen. To support the claim, and like we're doing everything else that A has. Paraphrase. Paraphrase. Okay. That's the 5 steps. And those are the 5 steps for the rest of the fucking semester. The only step that's really gonna change is step 1. Yeah, step 1. How we go about getting the test statistic in step 3 and Stack Crunch. That takes doing different things, but each one is related to step 1. Each thing we're gonna cover in the rest of the course will be like, it's just the 5 steps. If you memorize 5 steps, all you gotta really know is. How to pick H naught and HA depending on what your problem is, and that's what. Literally, the rest of March and all of April is to discuss. We got plenty of time to talk about it. Which means we're gonna have plenty of time for you guys to work on a project. I think we're starting that, we'll go over the project on Thursday. After I cover 10.3. Most people hate the idea of the project, and when they do it. They're like, oh, that was actually kind of fun, that was interesting. Alright,
This will be the project where we work with, right?
yeah. So I will talk about it and like I hated group projects as a student myself. Because I always ended up carrying dead weight. Someone that didn't fucking contribute, but we're gonna play snitch on my teammate here. And everybody will turn in like a slip of paper after your presentations and go. Do you say everyone worked equally or? Krista didn't do shit. You know she didn't do shit, so I can pick on her again. And if everyone says Krista didn't do shit, but she's like, we did it equally, I'm likely to believe the rest of her fucking group over her. Not just because it's Krista, because the majority wins. So if you could sabotage a teammate. You really don't like working with them, they're like, this person's an asshole. You could all gang up and say they didn't do shit and but that's unlikely. Alright. We did. A card example at the beginning of this class, didn't we? Let's do the 5 steps of the hypothesis test for our card example. I'm spelling it wrong. On our card drawing.
I had a good card.
You weren't here, show up on time. Krista wasn't here either, she didn't get to play. Not everyone got a card, Val got 2 cards, she sucked at it, she
All the
lost.
time. You should let Krista pick one, do like a Hail Mary sort of thing.
Wow, what about you, Val?
Oh. Or. Very clear.
You draw a red card, you get extra credit on the final, so does everyone in the class. Draw a black card, you get an extra question. Still wanna play?
What was the, what did you say, the,
You get a red card, get extra credit, you get a black card, get more questions. More questions than this. You wanna play?
No, I don't care, like, sure. Wait, but is there actually red cards there? Because they're all over black. How do I know?
Yeah. That's the point of the hypothesis test, you're not gonna know. I'll show you guys later after we go through the hypothesis test. Another black card.
I don't know.
Alright. We're done with that, let's go on to talking about here. So. When I opened the deck in front of you, and I did, I did it on camera, we unwrapped the cellophane, swept up in here. Had to cut through the goddamn seal they have on it, they put that seal so like. People can't stack decks at a casino and fuck over the, like, people. We could say our hypothesis was the. Probability or proportion of getting a black was 0.5. In a standard deck of cards, I'll use BL for black. Now. Krista hypothesized, she doesn't know that there's a red card in there. What would that mean in terms of an alternate hypothesis here? Is the proportion of black cards higher or lower if it wasn't a fair deck?
Black one's higher.
Higher. So the proportion of black cards would be higher. That's step 1. Step 2. Let's pick an alpha. How important is it that we're right in this? You guys just wanna go with 0.05 for now?
Yeah.
Step 3 is stat crunch. We are gonna do stats. Proportion stats. One sample. Now, before we do this, and we're not gonna meet the criteria, because I don't wanna do it enough draws about they meet the criteria. But in general, you want to have. For this to work, we require. It's the same thing as we had for the confidence intervals. N times P times 1 minus P. Has to be greater than or equal to 10. And N needs to be less than 5% of the population. Go to stat. And go stats. Portion stats, one sample. Let's go with summary so that I don't have to enter in that you got black 9 times. So we're gonna call drawing, since we're talking about black cards. We're gonna call drawing a black card a success. So out of 9 different tests. 9 people we had 7 before Arturo and Krista drew a card. We drew 9 black cards. The hypothesis test is already set up for the equality sign on P. We did proportions, so this is automatically fills in P. For black, it defaults to 0.5, which happens to be what we want here. We said that we think that the probability of black was higher. So you're gonna have to change the symbol on HA. Always check your symbol on HA. Always check symbol. With that in there, we'll click compute. And our test stat is the 3. So I'm gonna write this down and I'm gonna write down this p-value. So this is what we got from StatCrunch. I got my test stat, which is a z-stat here. On the final exam, it's not gonna say z-stat, it's just gonna say test stat. I got a 3, normally there's a decimal, that's weird that there's no decimal here. And I got a p-value of 0.0013. I'm literally writing down these values right here. Step 4 was make a decision. Compare p-value and alpha. I have 0.0013 and alpha was 0.05. This was my p-value and this was alpha. Is the p-value less than or greater than alpha? It's less than. So if the p-value is less than alpha, what verdict do we make? If the p-val is too low. Reject the hoe. Which means we're gonna support HA. HA was the probability of black was higher than 0.5. So in step 5. There is sufficient evidence, because we're gonna support it. Sufficient evidence. To support the claim. That the proportion of black parts. Was greater than 50%. 0.5 or 50%. And I'm gonna say. At alpha equals 0.05 level of significance. And then for bonus text, this means Pepe is a cheating fuckface. For rat bastard, cheating fuckface works.
Yeah.
How's it going?
Ready for the grand reveal? Did Hefe fucking cheat you guys? I mean, yeah, that's really? Do you really think that?
What's the likelihood that nobody would have grabbed a red card?
Yeah, that's fucked up. You should have let
You're
everyone.
all accusing me of
Should've let
fucking
every-
dishonesty, you're a
should've let-
teacher.
Should have let everyone else pick. So
No, I gave everyone the option and no one else wanted to. You really don't look like cheese. You know I'm in charge of your grades, right? That really fucking hurts my feelings.
I said your hair was nice.
that's fucked.
No, I'm not gonna put extra questions on your test, I don't wanna fucking grade that. And no, you never had a chance at extra credit. It does show the hypothesis testing process. Normally, you don't know the results. You go with what the test tells you. Okay? Here you know. I actually have 2 versions of the slideshow set up, one that says black, one that says red. And I had them both on a computer and I didn't know which one I was opening until I unsealed it. I did unseal it, but before I did it. I cut the bottom away and fucking swapped it with another mixed 2 decks. They didn't come that way. I just made it look like they came that way. Yes, I was a cheating fuckface. Alright, so let's continue on, we'll talk about this, do another example or so. We require these tests right here. This requirement is because. This makes it normally distributed. And the hypothesis testing with the p-value only works on normal distributions. Hypothesis test works for normal distributions. So in 10.2, that's actually what we're doing. 10.2 is on a one sample proportion test, which is what we just did. Our H naught. P is gonna equal some value. And HA, P will either be less than, greater than, or not equal to the same value. We don't mix them up. If we need it. If we need the mu or standard deviation for P. We did this before with confidence intervals. We're gonna use the P from the sample. And standard deviation will be the square root of P times 1 minus P over N. This is the same as the confidence interval version. And just so you have it all on one page. I'm gonna list the requirements again. N times P times 1 minus P should be greater than or equal to 10. And N needs to be less than 5% of the entire population. Yeah, I did that at my lecture. I cheated all the teachers that were present.
Still became a teacher.
They were my former teachers too. I was a COS student. I interviewed with people that had been my teacher. No. Yeah, one of them was my, they try to avoid having anyone that was. If like a student comes back to apply for teaching them, they try to avoid that to avoid any bias. But the selection committee had already been made and I applied. So let's do an example. This happened. During the pandemic. There's a lot of online classes, right? And us teachers realized that not very many students wanted to take face-to-face classes. In fact, more students would take online classes if they had the choice. We believed. That less than 40% of students. Want face-to-face. Courses. I'm gonna say stats classes here. Cause this is really all I have data for. And it might be different in other things, but. As compared to online. So fall 2021, what rolls around? And we check. Here's a table of what we had. This is only stats classes. So I'll have a face-to-face column and an online column. This was map 21. And I'll do a second row of map 21 with support. Hundred and 35 student wanted face-to-face for map 21. 550 wanted online. The support version, it was a little bit closer. It was 254 versus 241. That face-to-face was higher with support. So if I total up each row, this is 685. And this is 489. 485. 495. Hard to add, David. Which gives us a total of 1,180 students that took math 21 courses that fall. And if I add these up. There was only 389. Okay. So if I wanted to find a p hat here. I'm gonna show you these up here and then we'll do the hypothesis testing. Our mu of p hat is gonna equal p, which was 389 out of 1,180. That wanted face to face, since we're talking about face to face, that's what we're going to use. This is 0.32966. Standard deviation is the square root of p times 1 minus p over n. If I do 0.32966 times 1 minus that. And then divide by 1,180. If you throw that all that shit into the calculator, you're gonna get 0.013685. We're gonna use that in a second, but we're gonna do the hypothesis test, and then we're gonna use this to look at a confidence interval and a normal calculator and see how all this shit compares. We're almost done.
Daniel, yo no sé, yo no sé, Daniel.
I had students before accuse me before even drawing a fucking card. That deck is rigged, I'm like. Just fucking watch me open it, we don't trust you. Like, wow, I hadn't even drawn a fucking card and you don't trust me? That's cold. It was warranted, but it was cold.
Okay, after the second part that was drawn, I was just, yeah,
Usually people assume that around 5 or 6 cards. You can think you're unlucky in the beginning, but after 5 or 6. You instinctively know that this has got a low chance of happening. Or if you're doing the math in your head, you know you have a low chance of it happening, but those people don't. So let's do our hypothesis test with this. What is our H naught? Remember, it is what is the assumed value. It's 0.4. Don't go with what we calculated. Go with what we have up there. And that's from the 40% that we talked about. What was the teacher's plan? It was less than 0.4. Now, when we go to StatCrunch, we actually just saw our successes was. The number that wanted it was 389. And our observations, which is N. Is 1,180. We're gonna need that in a second. That's step one. Step two, we'll go with alpha equals 0.05. And step three, we'll go through that shit in StatCrunch. I know I'm gonna get a z-stat, cause that's what I got last time, and I know I'm gonna get a p-value. Watching my barometers. Are we good? Okay. Oh shit. Zoom is fucking up, there we go, alright. So we're gonna go stats. Proportion stats. One sample with summary. We're gonna say 389 successes. Out of 1,180 observations. We had P was 0.4. And P was less than 0.4. I click compute. And I get a z-stat of negative 4.93. And a p-value less than 0.0001. Notice they tell us our sample proportion right here. That's what I calculated by hand. Let's go back to our document camera. And there's our test. So step 4 was make a decision. Decision time. How does p-value, which is less than 0.001, how does that compare to alpha, which was 0.05? It's less than. So what is our decision that we're making about H naught and HA? Support HA. Because we are going to reject H naught. Our statement is always about HA. We already assumed H naught was true. So we're not gonna talk about it, we're only gonna talk about whether or not HA is the correct value. So we're supporting HA. HA was, there was less than 40%. So there is sufficient evidence. To support the claim. That less than 40% of students. Want face-to-face stat classes. I'm very confident that the online stat classes. For fall of 2025 are gonna be filled up before 11 in-person. Classes, there might be an exception. If Stephanie Collier is teaching, students love the shit out of her. And we'll take her class. She tends to fill up classes faster than any other teacher here. I don't know if she's teaching online or not, online stats or not. Alright, so that's how we do the stats or the hypothesis test. Let's go back and look at how we got, give me like 2 minutes to do this on StatCrunch, show you how this wraps up. Since this was a left tail test. I'm gonna do 1 minus 2 alpha. 1 minus 2 times 0.05. Is 1 minus 0.1 or 0.9. I'm gonna go for 90% confidence interval. I'm gonna show it to you on the confidence interval thing, and we'll also look at the normal calculator, and then we'll be done. See how all this shit ties together.
More, is you ready to go?
Now a lot of people are ready to go. For those that are writing, can I switch over and do it and then switch back and let you guys write so that the people that are fucking bag packed at least see this real quick? So I'm gonna do the same thing, stats, proportion stats, one sample with summary. We'll do the confidence interval, I'm gonna do it at 90. We had 389. And 1180. And our confidence interval has a lower limit of 0.307. And an upper limit of 0.352. On a bell curve kind of thing. The 0.307 is right here. The 0.352 is right here. And our target proportion, 40%. Is way over here. So we are outside the confidence interval. And when we're outside the confidence interval, it's effectively rejecting. Okay? And then to tie this into how this all shows up on the normal calculator. Stats, calculators, normal. We calculated the mean at 0.32966, it's right here. Same as Pete. And our standard deviation we did by hand was 3685. And we're gonna say the probability that X is less than 0.4. Do we have less than? Yeah. So this value right here is effectively I do 1 minus this. This is like our alpha, like equivalent of alpha, it's the p-value, it's the opposite of the p-value. If I do 1 minus this, I get that. If I do between. I say 0.9 here. Notice that on the normal calculator, the confidence interval, the 0.307. Well, if I round to 4 decimal places, I have 0.3072. And if I round to 4 decimal places there, I have that one. 0.4 is outside of it, so we reject it. We'll talk about how they tie in more later on. You're free to go. I'll put this back for people that were still writing. Oh. There we go. No, okay. We'll do 10.3 and then we'll talk about the project on Thursday. We'll probably have a short class. 10.3 is not gonna take that long, and it depends on how long it takes you guys to decide or how much time you want to talk about projects. I'm not picking teams for you guys are gonna pick them. Have a good evening.
Oh my god.